Here we are interested in installing GNURadio in a VirtualBox or Linux machine. So we check out the website of the GNURadio and we can see there's a number of possibilities. We can install this with the package manager with the sudo apt install GNURadio. We can actually use a PPA as well. Let's see, that's on this next page. So this is specific for the Linux installs, and we can do this from binaries, which is what we are actually going to do, just to give that a try and to have the latest version of Ubuntu. But it's not necessary to do that. You can actually get to, for Ubuntu here, you can use the apt install GNURadio command. You can also use a PPA installation. That's the advantage of being a little bit more recent. They update those more quickly than the apt packages. And then finally there is the installation from source. Now in either way you have to be aware that there is a certain order of installation that is needed, and I think we see this most clearly if we do a binary installation. So there is the GNURadio software, but there is also the UHD software, which is the driver for USRP devices. So those are software-defined radios that are not at the very bottom of the price scale, but also not all of them at the top. So you get USRPs for maybe close to about $800, $900 or so at the lower end, and they are very useful devices. So the thing is though that you need to install the UHD drivers before you install anything about GNURadio. So if you plan at some point in time to use one of those devices, it's best to actually install it even if you don't use it later. Then there is Volk, that's the package that does the arithmetic computations. I think Volk stands for Vector Optimized something, LK, it's not written here exactly, but it's an abbreviation, and it basically optimizes the computations, the vectorized computations for the particular CPU that you have, and there is a way then to further optimize that once it is installed. So Volk used to be part of GNURadio, but they have factored that out, and that needs to be installed separately as well. And then after you have done the UHD installation and the Volk installation, then you do the GNURadio installation. So let's go and take a look at our virtual machine here. So I'm starting it, and while we do that, let's take a quick look at the prerequisites on installation that we need. Let's see if it says here, somewhere here it says, for example, so installing dependencies. And then, for example, on Ubuntu 22.04, you use this page. So that's this page over here. And it shows you the kind of programs that you have to have installed for GNURadio even wanting to be installed. So what we will do is we will take a copy of those and we will just bring it over to our virtual machine and then install those things first, and then we will do the UHD installation, and then followed by the Volk and the GNURadio installations. Okay, so here is our virtual machine. We're gonna log in here. And then we bring up a terminal, Alt-Control-T. And now we go back to the GNURadio installation page. We just capture all of this here. and you need to have the capture option, or the what is it called, let's see, devices, shared folders. It's not it's a shared clipboard that you need to have enabled. So we have the shared clipboard here on bidirectional. Okay, so I can put that in here. So we paste that, and then we do an enter, and then it wants to have the password because of the sudo. Okay, and so it will install quite a bit of software here. So we're going to say yes, that it should install that. Then we're going to stop it for a minute so that we don't spend all our time watching how this is getting installed. Okay, so this has completed now. There are a few more packages that, in addition to this, have to be installed for GNURadio 3.10, which is the current version of GNURadio. So let's go back to the GNURadio website, and then we can see there are additional packages for 3.9x if you choose to install an older version of GNURadio, which we are not going to do. And then there's this one here, which is required for GNURadio version 3.10. So we copy this over to the Linux version in VirtualBox. Okay, paste that in. So that did not work quite well. So we have to go back here and put this in again. Okay, so now we go and then do that. So this is shorter for installing. And then the next step that we're going to do is we're going to take a look now at the packages that need to be installed for the UHD driver. So this is from the Atos website, and it's actually here. This is on the atos.com website under manual page build guide HDM. And so here we can see setting up the dependencies on Ubuntu. So we go here and copy this over and go back to our Linux machine. I usually use apt, not apt-get. So let's try to see. For some reason I cannot get my cursor to go there. So let's just use it the way it is. Okay, so this is going to take a little bit, so we will stop again for a moment. Okay, so that was successful. And what we need to do now is we are ready now for installing UHD, so we need to go and clone this. The instructions are somewhere here probably. Getting the source code, yeah, there it is. We clone it from here. And that should not take too much time. There it is. So now we so you do that in your home directory. I forgot to mention that, but we were in the home directory anyways. So now we go into the UHD directory, which is the part that we just downloaded or cloned from Git. And then we have to check on the versions that are available. So we do a git tag L. Okay, and so that will give us a whole bunch of lists here. It goes way back to older versions. The current version is 4.4. So what I usually do is I do not use the exactly newest version, but something that's close to the newest version. So I'm going to use version 4.3. And so what we're going to do is we're going to do git checkout and then version 4.300. Okay, and then we go into a directory which is called host. And that's basically the place where we are going to do the compilation. So now we make a directory build. We go into this build directory. And then we have to do the cmake. So that basically prepares things. It checks whether we have all the necessary programs and so on to then eventually compile things. So it's dcmake. There are some switches here that we have to set. It's actually dcmake here. Install. And then the prefix. So we install it in what's kind of considered the default prefix for GNURadio. So that is USR and then local, like this. And then we put the 2 dots and slash, so that basically goes up one directory level for doing the cmake. So now it is checking that we have the right prerequisites, and it seems that it is happy. It says that the DPDK is a disabled component. I don't know what that is, but I have not had problems with that previously. Okay, so that went through basically, and so now we can actually go and use the make command, and there is an option here is J3, so that's basically using 3 parallel branches of doing that. Okay, and so this is taking a while, so we're gonna stop again. Okay, we're back. This did actually work without any problems. And at this point, the C code has been compiled. And what we need to do is we need to now actually install it. So we do a sudo make install. Okay, so the compilation probably took on the order of about half an hour. The installation goes pretty quick. And we also have to do a sudo ld config so that the configuration is actually getting loaded. And then comes another part. The driver is now installed, but the different USRP devices, they have FPGAs in them, and they need to be, those FPGAs need to be loaded at the beginning when you use one of those devices. So we have to download those FPGA images, and we do that by doing sudo UHD images, and then downloader. Okay, so it actually starts an inventory file, and then it downloads those different things. So we will stop here again for a minute. Okay, so this is complete. Now the next thing we need to do is we need to set up the rules for actually connecting devices. And we go to the UHD utils directory, and then we copy sudo cp the UHD USRP rules to the etc udef rules d directory. And then we have to load those rules. So sudo udef adm control, and then reload rules. And then sudo service udef restart. For some reason, last time I did this, I had to run this a second time. So let's do the reload of the rules once more. And then sudo udef adm trigger. And at this point, the UHD installation should be complete. What we're going to do now is we're going to check that. I'm going to use this device here, a USRP 205 mini, which is sort of the smallest of the higher end SDRs. It has a frequency range here from 70 megahertz up to 6 gigahertz, so we can pretty much span the whole band. It doesn't unfortunately go below 70 megahertz, so we cannot use, for example, AM radio with it. You have to use different SDRs for that. So at any rate, let's go back, let's connect that thing. So now we have to go to devices on our VirtualBox and to USB, and then we can check what we have here now. So we have the different devices here, USB bridge, unknown device, and then a Cypress West bridge. That's probably the one that the USRP is connected right now. So let's click on that, see if it is doing something for that. Yeah, let's actually go here. Let's add that. So the Cypress West bridge. And then we're going to take a look whether that actually helped. So let's do actually what I'm gonna do first is I'm gonna do an a check on what's there in the USB port. So ls USB, listing the USB devices. So there is something there, but it doesn't look right now yet like we have the right one. But let's try to connect here UHD USRP probe. So it says that it doesn't find the command HD USR. Oh, I misspelled it. Okay, it says that it cannot find devices for it. So what we have to do is we have to go back to the devices and settings. And then so last time when I did this, there was actually an Atos device showing up, but I don't see that right now. So let's see what we have. Let's try the unknown device here and see what that is doing. Back here again. Okay, that still didn't work, so I'm gonna stop here and investigate this. Okay, so it turns out that there is another USB that needs to be used, not the Cypress one. So this MCT Corp seems to be the one that it likes. So let's go back and look at the settings here, and let's add that MCT Corp. I'm using a dongle actually to connect to the USRP, so that is probably the name of the dongle or through the dongle. So now if I'm trying to do again the what was it, UHD USRP probe. Okay, so it says something about UHD here, which is a positive sign. And now we need to go back, and now hopefully there is going to be something showing up that has to do with the Atos controller. Okay, I did get it to show up one time, but now it doesn't appear anymore. So let's do an LSU SB. Let's pause here again and debug this whole thing. So this can be a little bit tricky, unfortunately, to get that connection to the USB device. What I ended up doing is I got out of the virtual machine and started it again, and then I tried a couple of times disconnecting the USB connection and connecting it again, and eventually it actually showed me this line here, loading firmware image, which is a good sign. It could still not find an actual device, but the reason is that I was using here for the USB settings that unknown device 2500, and then it was able to connect and realize that it should load some FPGA firmware, but it's not the correct name of the USB thing, but it came up here now with the Ethos Research LLC unknown. So we're putting that one in now. And then we try the UHD USRP probe again. And it's not yet happy, so maybe what I have to do is I have to remove that device here. And then it has the Ethos device, and now let's see what it does with that. Yeah, I'm still not happy with that. But it is definitely some progress that we are seeing, this Ethos research device here. And so we get to see now that the vendor ID is 2500 and so on, so we can actually know now that this kind of device would be the one that it's liking. So let's try once more to go here and look at that. So it does fill in all the right parts here. So what I'm going to do now is I'm going to actually restart the virtual machine again and see whether that is going to help. Let's just try once more. I don't think it's going to do anything yet. Yes, but I'll restart and then come back again. So this does actually work. Eventually, I had to plug and unplug a couple of times the device that I wanted to connect, the B205 Mini, and eventually it did show up. So I went under devices and then the USB settings, and then you have to click on the device, that Ethos Research LLC unknown, and you have to have that little check mark in front of it so that it's actually connected from the host to the guest machine, which is the Ubuntu here in the VBox. Okay, and then when you do this and you now run that UHD USRP probe, then what you should be seeing is something like this. So it's loading the driver and it gives you the information of the device that's connected. So in this case it's that, let's see here, that B205i board, that's the B205 Mini that we were looking at. Actually it's written up here. Okay, so it does work, you can connect it, but it is a little bit tricky at times, as you could see, to really not let Windows capture the device so that it's actually available in the VirtualBox. We can also look at LS USB just to see what's connected now, and we can see that there is this Ethos Research LLC USRP 205 Mini, so that indicates that it's actually talking to the device. So now we have to move on. We have now at long last installed the UHD driver, and now we do want to install the Volk. It stands for Vector Optimized Library of Kernels from source. So we go back to the home directory. We are actually in the home directory already, but if you are somewhere else, you need to go back, and then we do a git clone recursive of https, and then github.com and GNURadio and Volk .git. Okay, let's check that we type this right. I think it's okay. So it's cloning into that, and then we go into Volk, into the Volk directory, and we make a new directory which is called build. That's again to run the C code, to compile the C code eventually. And then we go into this build directory. Then comes the cmake command, which requires a little bit of switches in there. So there is a dcmake build type, which is set to release. Then there is the dcmake install prefix. That is equal to our USR local, like we did it for the UHD driver. And then we have to tell it about Python, and so we do a d Python executable. And that happens to be in the standard location, which is USR bin Python 3. And then we invoke the cmake program that's one directory level higher. Okay, let's try that. So it's again checking whether we have all the programs and requirements set, and it seems to be happy with that. So now we do the make command, and that's the command that takes a little bit. It seems to actually not be too bad in this case, but we might just stop it here anyways for a minute or so. Okay, that worked. It took maybe about 5-7 minutes or so. So now we can run the tests. So that would be make test, just to make sure that it's all going through. And it did pass all the tests, so that's fine. So now we can install it. Sudo make install. And then the sudo ld config. And now we are finally at the point where we can actually install GNURadio. So we have to go back to the user directory. In fact, let's even use a new tab here. Control-Shift-T makes a new tab in the terminal. And then we do a git clone https tab. Then it's GNURadio and GNURadio git. So we got that. And now we have to look at the versions available. So we do the git tag L. Let's see, that did not quite work yet. Oh, I did not go into the GNURadio. Okay, so we go into the GNURadio folder. Then we do the git tag L. And you can see that it starts out actually with relatively early versions like 3.3, 3.5 and so on. Those are not the versions that we want to have. Now we're getting to the 3.10 version, which is what is going to be interesting. I think there is also a 3.11 version, which is still a bit experimental at this point. So we're going to choose the version 3.10.7. Here are some more versions that could be used, but we're going to check out here the version 3.10, 3.10. 7.0. Okay, and then we do the usual thing here. We make a build directory. And then we do the CMake with the switches. So the DC make build type is release, and then the DC make install prefix is equal to the USR local. Then the dpython executable is equal to the USR bin Python 3. Okay, and then we refer to the higher directory level for the CMake program. Okay, and it seems to be happy by and large. So what we have here now, we do the mkdir, not the C. It actually did not. Oh, it has some disabled components here. I don't know if we want this. We check on that. I think I would like to have the Python support and the GRSOP. So let me stop here and find out why it is not doing that. So looking through the CMake comments, we can see that there are a couple of brown ones here. So there's, for example, the PyQt graph and SciPy seem to be missing. There is something up here, mass checks is missing, and one of the important ones, the PyBind 11, was missing. So what we have to do is we have to install a couple additional things here. So I figured out what is most likely what we need. So there is this whole thing here that we are going to copy over. Okay, didn't copy it right yet. So let's do it once more. Here. Okay, so it's sudo apt install pybind 11 dev, python 3 matplotlib, libsnd file 1 dev, so those are sound files, python 3 pip, libsoapy sdr dev, libsoapy sdr-tools, libio-dev, libad9361-dev, so that's used for the analog devices, A to D and D to A converter thing in the add-on 2000, and then libspd-log dev, python 3 packaging, and python 3-JSON schema. Okay, so let's enter that here, and then the password, and because I installed it already, it shows that it's already there, but it was, those packages were missing before. And there is a second command that we should run, and that is this one here. Oh, we got it. Okay, so this is the PyQt graph is in here. That's what's needed for actually displaying graphs and things in GNURadio. So we do want to have that. Okay, so let's run that as well. And it again will tell me that it's satisfied already because I actually installed it in the meantime. So now we go back to our cmake command, and we will check whether it's now installing those components that it did not want to do before. Okay, so far it's looking good. It's basically different modules that make up the whole GNURadio program, and you can now see on the GNURadio disabled components there is actually nothing anymore. It has actually found all the components. The build files have been written to the build directory, and now what we can actually do is we can run the make command and then sit back and wait until it has been doing that. So it's still talking about some problems, so we will check whether it works. So it does seem to start making the program. Okay, so this is typically taking quite a while, like on the order of an hour or 2 hours. So we will stop the recording now and then come back when it has done its compilation. Okay, the compilation completed here. It maybe took about roughly an hour or so. I could probably have run a make with a -J3 to have more processing cores involved, but the main thing is that it worked, and so now we can do the make test to basically run some little test snippets that check whether everything is working the way we would like to. Okay, so it does test the different modules within the GNURadio framework. And then once we got that done, we will be able to do the make install and the LD config and then there is one last step. We do want to run the Volk profile in order to optimize the execution of those vector optimized libraries for computation for the particular CPU that we are using. Okay, I don't remember anymore how many tests there are, so hopefully this will be done soon. Okay, there we go. And it passed all the tests, so now we do the sudo make install. Okay, so there's some documentation. And now we can do the sudo config to load the configuration. And then we're going to do, let's actually go back to the home directory, and then we do the Volk profile. So it's making those tests. That is taking a little while, so I'm going to stop it here. So now the tests are completed, and they are written there to this.volk /volk config. And now comes the great moment when we can actually try GNURadio. So I'm gonna make a new tab here on the terminal. I'm making a directory, GNURadio experiments. So we go on, and then we make a directory test 001. Then within that we're going to type now just GNURadio -companion, and that should bring up the GNURadio program. There we go. And to do a simple test, what we will do is we will just take a waveform generator and make a variable frequency and then display that on an oscilloscope. So we go here to waveform generators, and then we pick signal source. So we double click on that, so you get the source here. And then we want to make a variable frequency, so we go to here GUI widgets. And then we are going to take a Qt GUI range. Okay, so we put that somewhere up here. And we're going to make this some frequency, let's call it F0. And the default value, let's say we're going to make this 1000 Hertz. And we're going to make this go from, let's say, 20 Hertz to maybe 10,000. So this is the range over which we can choose the frequencies. And then we need a throttle. So that's on the miscellaneous. So that's further down here. Here. Okay, the throttle is needed because we're running this just only in software. And so there is nothing, no hardware that's actually dictating at how much speed this whole thing is going to run. And the throttle is basically trying to make it run just at the speed that's given here, which is the 32 kilosamples per second. This can of course be changed, but for our little example that's good enough. Okay, so now we want to have the instrumentation Qt, and then we want to have a Qt GUI sync like this. We can actually use a mass operator. The interesting thing here is that this blue, that means it's a complex valued output. I think if we go under help, we can see some of those things, types. Okay, so we see the different colors for different types of connections, and the blue is complex float. There is an orange one here which is just float 32, so that's just real valued. And what we want to do is we want to find here a conversion from complex to real. Let's see where that is. Okay, I don't see it immediately. Okay, let me find it. Okay, it's actually not under mass, but it's under type converters. So we go here to type converters, and then we do complex to real. It's this one here. So we add that in parallel with the Qt GUI sync, and then we actually can put the speaker here, so an audio sync. And in fact, if we do that, then we don't need the throttle anymore. Audio sync. This because now we have an actual hardware device, just the audio sync, so we are going to bypass this. So you just select it and you type B, and then it gets bypassed. And so now let's save that. So let's call it audio test. Save it here. And then we can try what happens if we are running that. Okay, there is a little error here. I can go back here and take a look at what is the problem. The audio test has no attribute blocks throttle 2. So let's check what that is. I will pause that. So there is actually not a problem with anything. One of the messages here is that ignoring XDG session type Wayland on GNOME. So that's just a different type of communicating with the desktop, and we don't have to worry about that. But there are some other little problems that we should probably correct. For one thing, we don't have a volume control, and then we also forgot to actually use that F0 here, which is the variable frequency, to pass that on to the signal source. So what I'm going to do is I'm going to select all those blocks, move them down a little bit to make space, like this. Okay, and then I make a copy of this one here, Control C and then Control V. Okay, and then I'm going to make this just a capital A, and that's going to be my amplitude of the whole thing. And I'm going to go here maybe with a default value of 0.2 and with a start value of 0, so that we can turn off the volume up to a stop value of 1. And then we have to make the step a little bit smaller. Let's make it 0.1. And then I have to disconnect this one here and put the multiplication inside. So I go back to the mass operators, and that would be multiply by a constant here. Okay, you can see that the default of this is to actually be complex valued. So we can just click on it and then use the down arrow to convert this to just a real valued block. Okay, and then instead of the constant of 1, I'm putting in that A that we defined. Okay, so it gets multiplied by A, and then the F0 from up here I'm going to put over here on the generator, and instead of the fixed 1000 Hz frequency, I'm just making this F0. Okay, and so now we can probably take again, so I'm going to do a bypass, and then I can run it again. So now you get to hear the sound, and it's not a particularly pleasant sound, but we can change the frequency now. Okay, and you can see in the spectrum that this is moving back and forth. We can also look at it in the time domain, so we can try to make a much smaller frequency. Let's actually turn the sound back a little bit. So we can make it a much smaller frequency so that the spacing is bigger. It's a complex valued output. When you look here, it has blue. And complex valued output means that you produce an e to the j 2 pi f0t, and so you produce actually a sine and a cosine. So the real part, the blue here, is the cosine, the red is the sine in this whole thing. I did not make any change in amplitude for going into the instrumentation display, but it could of course be changed as well by using this A. I only put the A for the speaker. Okay, so if I want to put on the speaker again, we should be able to hear the sound. So that works quite nicely. We can also do a waterfall display, and then we get to see the frequency over time. So if I move this then you will see in the waterfall display that the curve there, or the red part in the waterfall is actually moving to the right, and if I move it to the left again, then it will go to the left. Note that my lowest frequency right now is close to 0, 20 Hertz. I could actually have made it such that I have both positive and negative frequencies, because I'm using here a complex exponential generation, not a real valued generation. So let's actually turn this off for now, and then let's make a little change here. In fact, maybe what I want to do is I'm gonna take out the throttle block, and I'm gonna take that multiply constant and move that in here and make it back to complex again, so that I'm actually not only changing the volume of the output, but change the volume altogether. Then I connect the audio sync again. Here, and then we're going to change the frequency so that we actually can go from, let's actually not make it all the way to 10,000, but maybe to 2,000, but start at minus 2,000. Okay, so now we're running this again, and now you will be able to see that I can actually change that frequency, go to low frequencies. Then over to the negative side. Of course, we do not hear a difference because we're just listening to the real part. And I can make the amplitude a little bit smaller here. But we do generate positive and negative frequencies for the exponential, the complex exponential version of the signal that we are generating. So that's kind of nice to be able to go between negative and positive frequencies when you generate a signal for purposes of communication systems. Okay, so we can turn this off. And now we can also try to actually use our USRP, the B205 Mini, to make a new flow graph. So we make here a new way, and now we're going to make the sampling rate higher. So we're going to make it something like 1E7, so that would be 10 megahertz. It has to be an integer, so we write here integer of 1E7. Okay, and then we're going to go to the UHD here. So that's what we installed as a first thing, and we're going to do a USRP source like this. Then we're just going to use an instrumentation here, a Qt GUI sync, to see whether there is anything interesting to see. The frequency domain. We have to choose some frequencies. So we probably want to do that using a Qt GUI range. And maybe another one of those variables. So let's copy this one and then paste it. So what I'm going to do is I'm going to choose another one of those Qt GUI widgets, the range here, and make a variable frequency range. Let's actually take a look maybe at the FM band. So as a default value, we could choose say 100 megahertz, and we could start at about 80, and we could go to about 120. Okay, and we change this in 0.1 megahertz and 100 kilohertz steps, and we have to give it a name. So this is going to be the carrier frequency, so I'm going to call it FC. Then I need here actually I'll maybe call it FC in megahertz, just to make clear that what the units are. And then I'm going to make a variable here, and I'm going to call this actually FC. That's the frequency that we're going to feed into the software-defined radio. And this is going to be FC in megahertz. And then 1e6 times that. And it should also be an integer probably. So it's an integer in hertz, not in megahertz. Okay, and then we can put the FC in here somewhere. So there's a general setting. I think we can probably leave this more or less as is. And then we go to the RF options. And here we're going to put the FC frequency. Bandwidth, I think we leave it at 0. I think that makes an automatic bandwidth. The gain type, dB. Let's leave that in dB for now, but we want to make probably about the 40 dB gain to get the good signal. And now I think we can take a look at that. What we want to do maybe is we want to make the center frequency here into that FC, so that we can see what we are tuning to. Okay, so let's see whether that works. So this would be, say, an FM spectrum. Okay, so it's sending things to the software-defined radio. Right now, I do not see any signals here. I can go and try to change the frequency. Somewhere there must be my frequency change here. Okay, there's nothing here, so it's possible that I have not used the right input at the software-defined radio, so I'm going to change that. Right, so I used the wrong input, and now you can see that there are those peaks in there, and those are peaks that come from radio stations. So if you go a little bit further down in the FM band, you can see some of those. So there's a station, for example, here at about 94.6 megahertz. We can increase the average so that we get to see less noise and more peak, like this. So now you can see that there is actually some signal somewhere out there. if we really wanted to listen to those signals, then of course we would have to build a receiver. We could also try to actually increase the gain a little bit. I'm indoors, so it's not necessarily the best reception environment. So let's go here and make the gain about 60 dB. See if that works. So we do get to see some pretty good peaks, I think. Yeah, so here's this one at 94.6 megahertz again, so that looks pretty good. So as a last example, I made one more flow graph to look at LTE signals. In this case, in the 600 to 700 megahertz band, so it's higher frequency than we would have for FM, but the lower frequency than you would get for 5G for most 5G signals and so on. So I changed the bandwidth here to 20 megasamples per second, and I changed the gain back to 40 dB because those signals are pretty strong. Okay, so let's run that and see what there is to be seen here. Okay, so you can see there is a band of frequencies here that actually happens to be the T-Mobile downlink at about 624, 25 megahertz, and then right next to it there's a signal that's actually 10 megahertz wide. The T-Mobile signal is only about 5 megahertz wide. The next one is 10 megahertz wide, so that's AT&T at about 631 megahertz. If we average over those, we can see better the structure of those signals. They fluctuate, of course, as LTE signals do, but you can see here on the left the 5 megahertz of T-Mobile, and on the right the 10 megahertz of AT&T. So that basically shows us that things are working right. You can see when you go back here, let's see if we go back to this one, you can see that occasionally there are overflows occurring. That's because I'm running it with a 20 megahertz bandwidth, and going through the VirtualBox and everything, that puts things a little bit to the limit, but it's actually relatively few overflows, so it's actually working pretty well. Okay, so I think at this point I'm stopping this whole installation of GNURadio. I think we have successfully demonstrated that it's possible to do that. It's a relatively time-consuming process, and again, I point out that you don't need to install all of that from binary sources or from actually the sources. You can use pre-compiled binaries as well.